Hello everyone and welcome back. My name is Mr. Cobalt, and in this video we're going to go over how to calculate the vapor pressure of a solution given the masses of the substances that are mixed together in the solution, and figure out what the mole fraction of the components are in the vapor pressure. So let's get into this. Okay, so in this problem, we have a solution that contains 50.0 grams of acetone and 50.0 grams of methanol, and they gave us the formulas for each of those substances. The vapor pressure of pure acetone is 271 torr, and the vapor pressure of pure methanol is 143 torr. So that's the information they're giving us. And the first question they're asking us is, what is the vapor pressure of this solution at 25 degrees Celsius? Assume ideal behavior. Well, what does it mean to assume ideal behavior? That means that we're going to assume that the intermolecular forces that are acting between the particles in the pure substance is going to be the same as the strength of the intermolecular forces when they're mixed together. So we're assuming no change in the strength of the intermolecular forces when they are separate and pure versus when they are mixed together. That's what it means to be an ideal solution. Okay, so the first thing to do in this first part is to figure out what the moles are, because we need to use Raoult's equation. So remember, Raoult's equation is the vapor pressure of some substance A is equal to the mole fraction of that substance A in solution multiplied by whatever the vapor pressure of that substance A pure. So we put a little circle up there. So this is Raoult's law. So in order to do this, we need to figure out what the mole fraction is. So we need to calculate moles. So remember, mole fraction of a substance A is going to be equal to the moles of A divided by the total moles in the solution. So in this case, we have acetone and we have methanol. So I'm going to use A for acetone, M for methanol. So to find the mole fraction of acetone, I need the moles of acetone, and I'm going to need the moles of methanol and add those together to get the total moles. So they're giving me 50 grams of acetone, so I'm going to take 50 grams. So to find the moles of acetone, I'm going to take the 50.0 grams of acetone. I'm going to divide that by the molar mass. I can calculate the molar mass of acetone from the formula. And when I do that, I get 58.08. So 58.08 grams per mole of the acetone. And when I calculate that, I get 0.86, 0.86086. Now for sig figs, since I have 3 sig figs here, that's the least number of sig figs, so I would keep 1, 2, 3. Keep 1 or 2 just, to avoid rounding errors, but 3 is what I'm allowed finally so far. Now for the moles of methanol, so N sub M, so M for methanol. They give me again 50 grams of the methanol, and I'm going to divide that by the molar mass of ethanol. And again, they give me the formula for methanol, so I can calculate the molar mass. And when I do that, I get 32,043. So 42.043. Let me double check that. 32, not 42. 32.043. That is correct. And that's going to be grams per mole for the molar mass. And this is going to be moles, of course. Moles of A, which is acetone. And when I calculate the moles here, I get 156, 1.56040. And that's moles of M, or methanol. And again, since I have 3 sig figs here, that's the least number of sig figs, so I should have 1, 2, 3. So I'm going to underline the 6 there, but I keep a few digits. You don't need to keep more than 1, but you can. I like to keep more than 1, but 1 is enough to keep extra digit to avoid rounding mistakes. Okay, so now that I have the moles of acetone and moles of methanol, that's the only two substances in our mixture. So I add those together to get the total moles. So adding these together, add those together, I get 2.42, 2.42, is it 126? 126 moles total. Okay, so I have the moles of each individual substance. I have the total moles. Now I can calculate the mole ratio in the solution of each substance. So for here, it's acetone. So the moles of acetone, which is 0.86086, so 0.86086 divided by the total. And remember, when you add things together to figure out the number of significant digits you're allowed to keep, adding and subtraction requires that you pay attention to the number of the number of decimal places. So here again, I have 3 decimal places, 1, 2, 3. Here I have 2 decimal places. So the least number of decimal places rules. So in my final answer, I'm only allowed 2 decimal places. So I underline the 2, but I'm keeping extra digits because I have to continue with my calculations. Okay, so then here, I'm going to divide by 2.42126. So then when I divide these together, I get the mole fraction 0.3555. 0.3555. I think I have an extra digit there, 4. Okay, so this is the mole fraction of acetone. To get the mole fraction of the methanol, I just subtract that from 1 because all of the mole fractions in your solution add up to 1. Okay, so now to find the mole fraction of methanol, I'm going to take 1 and subtract out the mole fraction of the acetone. 0.35554. And when I do that, I get, what do I get? 0.646. And so remember, I have 3, I have underline the 0 there, underline the 2 there. So here I'm dividing. So I have 3 sig figs here. I have 3 sig figs here. So 1, 2, 3 sig figs there. Here I'm subtracting from 1. So I have 3 decimal places. So this will be 3 decimal places. Okay, I have the mole fractions now of methanol and acetone. So what is the vapor pressure of this solution at 25 degrees? So now that I have the mole fractions in the solution of acetone and methanol, I can now use that in the Raoult's equation. So now I can use this. So let's go ahead and erase all of this. I don't need that anymore. So what is the vapor pressure? So this is the vapor pressure. That means the total vapor pressure, not the partial pressure. So in order to get the total vapor pressure, we're going to have to find the partial pressure of acetone and the partial pressure of methanol. So we're going to use Raoult's equation for both of those. So the partial pressure of A is going to be, or acetone is going to be equal to the mole fraction of acetone, which is right there. So 0.35554, underline the 5 there, multiplied by the partial pressure or the vapor pressure, of acetone when it's pure. Pure acetone, we're given pure acetone, 271 Torr. So 271 Torr. And when I multiply those together, I get 9635, 96.35 Torr. And again, 3 sig figs, so 3 sig figs. And then I do the same thing for the partial pressure of methanol, or the vapor pressure of methanol at 25 degrees for this solution. So I'm going to use the mole fraction of methanol multiplied by the vapor pressure of pure methanol. So the mole fraction of methanol here is 0.64446 multiplied by the vapor pressure of pure methanol, which is 143 Torr. So 143 Torr. And that's going to be equal to 92.15. And to get the total pressure, I add those together. So 96.35 plus 92.15, add those together. So the total vapor pressure is going to be PA, the vapor pressure of acetone plus the vapor pressure of methanol. Add those together, and I get 188.5. 188.5 Torr total. So that is the answer for part A. Now remember, sig figs here. So here I have 3 sig figs. Same thing here. When I'm multiplying, my answer should have 3 sig figs. 1, 2, 3. So here, remember the when you're adding, it's not sig figs but decimal places. So here, when I add this together, my last significant figure is in the tenth place here. Here it's also in the tenth place, so my final answer should have the last digit in the tenth place. So this is the correct answer with the correct number of significant figures. Now, what about part B? What is the mole fraction of each component in the vapor phase? So now we want to find the mole fraction in the vapor phase. So here we're going to have to use the relationship between moles of a gas and the pressure of a gas. Okay, so let me come back. I'll be back with you in just a moment. Okay, so let's go back to the ideal gas law for a moment. So we know that the pressure of gas A is going to be equal to the, multiplied by the volume is going to be equal to the moles of gas A multiplied by R times the temperature. If we solve both of these, if we solve this for the pressure of A, then we get P of A is equal to the number of moles of A times RT over V. Now, this is for partial pressure. If you know the partial pressure, or if you're trying to find the partial pressure of a given gas, you could use this. But also the total pressure of a mixture of gases. So if you have P total, the total pressure times the volume is going to be equal to the total number of moles times RT. And since we're talking about a mixture of gases, all of the individual gases mixed together are going to have the same volume because it's in the same container. It's going to have the same temperature because they're mixed together in the same container. And so, of course, R is going to be the same. So if we solve for the total pressure, that's going to be equal to the total moles times RT over V. Now, if we divide these, right? If we divide these, since the volume and the R constant and T are all the same, so those are going to cancel out. And what you end up with is PA over PTOT, P total, the partial pressure of A divided by the total pressure is going to be equal to, notice that I have moles of A and moles, total moles. So that's going to be equal to the moles of A divided by the total moles. Well, what is the moles of A divided by the total moles? That is the mole fraction of the substance A in the vapor phase. So that's basically going to be equal to the mole fraction of A in the vapor phase. So why is that important? Because we can now use that and the information we have here. So we have the partial pressure of A, which is acetone, the partial pressure of M, which is methanol, and we have total pressure. So we can use the partial pressure or the vapor pressure of A and the total pressure to find the mole fraction of A. So let's go ahead and do that. So the mole fraction of A acetone is equal to the partial pressure or vapor pressure of acetone divided by the total pressure. Well, we already calculated the pressure, the vapor pressure of A and the total pressure. So we just plug those in. So the vapor pressure of acetone is 96.35 torr divided by the total pressure, which is 188.5 torr. The torrs cancel out, and when we do that calculation, we get 0.511. 0.511. And then to get the mole fraction of the methanol in the vapor phase, since again, those are the only two substances we're dealing with, the addition of all of the different substances that are mixed together is equal to 1. All of the mole fractions added together equal to 1. So to find the mole fraction of methanol, that's going to be equal to 1 minus the mole fraction of the acetone, 0.511. And when we calculate that, we get 0.489. Okay, so 0.489 is the mole fraction. So the mole fraction of acetone, the mole fraction of methanol. Okay, so now we've answered A and B, so let's go ahead and answer C. So it says the actual vapor pressure of this solution is 161 torr. What did we get? Our total pressure was 188.5 torr, right? So our calculated amount of pressure due to the two vapor pressures of methanol and acetone is 188.5, which is larger than what we get in reality, right? So 161. So the question is, if this is different from the answer you calculated in part A, it is, explain why. Well, what did we assume in part A? We assumed an ideal behavior. What does that mean again? That means that the intermolecular forces of the pure substances, of the particles, between the particles of the pure substances, will not change or will be the same as when you mix them together. There's no difference. So the intermolecular forces between the different particles are going to be of equal strength as the intermolecular forces of the particles when they're in their pure substances and not mixed together. Well, that doesn't seem to be the case. So first of all, the first part of the explanation is then this indicates that our solution is not ideal, because if we assumed ideal, we got 188.5. If our solution was actually ideal, we should have gotten the same partial pressure or the same total pressure. We did not get that we did not get that total pressure. So that means that our solution is not ideal. What more can we say? Well, if an ideal solution, in the assumption we are assuming that the strength of the interactions between the particles when they're mixed is the same as when they are not mixed, and they're only with each other in the pure substance, that doesn't seem to be the case. So if our vapor pressure is lower, that just means that we have less moles, right? Less number of particles in the vapor phase to give that pressure. Well, if that's the case, then that means that the intermolecular forces, the attractive forces between the particles when they're mixed together, is actually stronger, right? Why? Because if they're stronger, that means that they're going to hold on more tightly in solution, and then therefore less particles are going to be able to escape into the vapor phase and therefore add pressure. So stronger interactions means less particles in the vapor phase, which means less pressure in the vapor phase, right? So if the intermolecular forces between the particles when they're mixed together was weaker, we would expect more particles to be given into the vapor phase and therefore a higher vapor pressure than what we actually calculated. But since, sorry about that. But since the actual vapor pressure of our solution is 161 torr, it's less than what we expected based on our calculations. Therefore, that indicates that the intermolecular forces between the particles when they are mixed together is actually stronger than when they're separated. And so therefore, that would explain why we have a lower vapor pressure of 161 in reality based upon what we calculated, assuming ideal behavior. I hope that helps. I hope that was a clear and helpful explanation. I hope this video helped you out, and I hope you enjoyed it. If you did, then please like the video, share the video, hit that like button somewhere over here. Also, make sure you subscribe to my channel. Help me out, please. That would really be appreciated. When you do that, make sure you click on the notification bell up above and click all so you can be notified by all the videos I put out. And finally, put a comment down below. Excuse me. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or a problem you need help with, or if you have a topic you want me to cover, put that down below. I would like to do that for you. Thanks for joining me, and have a great day.